Today we are presenting Plants vs. Zombies Puzzle Edition, a complete reimagining of the classic tower defense game. We have transformed it from fast-paced action into a strategic logic puzzle. The original Plants vs. Zombies was all about quick reflexes and real-time reactions, and our puzzle edition replaces chaos with calculation. Now it's about logic. Planning under limited sun and command constraints, it requires pattern recognition to learn wave schedules, sequence solving to optimize your action order, and spatial recognition to position defenses effectively across lanes. We have designed 3 escalating difficulty stages: Garden Defense, Multi-Lane Mayhem, and finally the boss battle. So different stages has different new plants and zombies and different amounts of turns. So the core mechanics are simple. You work with limited sun points each round on a grid layout. Plants defend from the left, zombie attack from the right, and the key is strategic planning. You must place all your plants before the turn executes. Let me walk through a turn with you. So basically you enter the command, place the row number, column number, and the plant code in order to place a plant. For example, like we place 2, 3 pea shooter to place a pea shooter. So each plant costs sun, so budget carefully. So for our battle simulation, it's run automatically. Once you start, the pea shooters attack, and the sunflower generates sun, and the zombies move and bite the plants, and the new zombie spawn. And you may win the game if the gardens survive for the limited amount of rounds. All zombies must be defended, and no zombies reach your house. And you can see that we win this game because we fulfill all of these conditions. And you may lose the puzzle because the zombies reach your house or remain alive after the limited amount of rounds. Thank you.
Now I will provide an explanation of our design and programming technique of the plain part among the whole code. Key thing we use in our code is object-oriented programming inheritance. In OOP in Python, inheritance enables a subclass to reuse standard attributes and methods of a base class, promoting code reusability. Let's take the code of the plain part as an example. We have totally 7 different kinds of planes in our code, where the plane class serves as a base, and specialized planes like pea shooter and repeater inherits from it to act unique behaviors while sharing common properties. Starting with the base plane class, it defines core attributes like name, cost, max health, and so on as class variables for easy sharing across instances. The init program initializes health, while start turn and attack are placeholders, allowing subclasses to override them via inheritance. For pea shooter, here, a for loop scans right word for the plane's position using range to iterate columns efficiently, in times where n is board width. It checks for zombies with if tile zombies, then damage each using a copy tile zombies to avoid modification during iteration errors. Building on pea shooter's pattern, repeater uses a loop over shots. The outer for shot in 1 to 2 and inner loop with hit flag create independent firings, avoiding code duplication while allowing each shot to target dynamically. As for Sunflower, the code ties into the game's economy using direct state modification and logging for traceability. As for Walnut, with no overrides, Walnut relies on elevated attributes. And using this 2 nested loop and checkboard position enable proximity damage, then hurting zombies with this code for area effects. For Potato Mine, this base tile selection and exploded flag manage one-time destruction, illustrating event driving state changes. It will blow up for 4 damage and disappear if zombie steps on it. For Iceberg Pair, the setter triggers freeze attacker zombie functions, which sets zombie frozen time to 2 turns. Additionally, start turn function store different information, and trigger function can freeze on-step zombies. Finally, we use dictionary to map symbols to class metadata, facilitating dynamic instantiation.
Today I will talk you through this zombie code set for a tower defense game, which uses OOP ideas to build diverse zombie rules. Let's start with the basics. First, the core. Zombie basics class. It defines universal traits, name, maximum HP, speed, damage, and symbols. Its initial sets, initial HP and frozen state. The on-turn start reduces frozen time, and the move method is the key. It lets zombie move to the left, attack plants, and triggers a game over if they breach the left edge. This class is the template for all zombies. Next up are basic variants. The workers just boost maximum of HP T2, a symbol tweak, Vex Biter, double speed and damage, adding a spring log before moving. Gargantuan has 7 HP and heavy damage with a labyrinth log. This shows how addressing-based attributes creates different basic strength easily. And then comes skill-based zombies. Aroma has a shell that resets each turn, blocking the first hit. Camouflaged Zombie has a 50% dodge chance using random logic when taking damage. Healer does 0 damage, but heals nearby zombie 1 HP in a 3x3 area every turn, perfect for supporting. Well,